All right, today we're going to talk about graphing quadratic equations using the axis of symmetry, using the vertex, using a table of values, and then ultimately plotting all of our points and graphing them. There's going to be a lot of pieces to these quadratic equations, so that you want to make sure that you kind of find an organized way to attack these problems. We're going to start off with a very easy function. We're going to identify the axis of symmetry. We're going to identify the vertex. We're going to fill in a table of values. We are not going to use a calculator. Okay, we're going to get rid of that. No. Okay. And ultimately, we will be able to graph our quadratic equation. We're going to start off with a very simple function, y equals x squared. Okay. To find the axis of symmetry, we have to use negative b over 2a. And with our function right here, our b is 0. So we have negative. We're going to insert 0 here, parentheses. 2, our a is 1. Remember, there's a 1 that hides in front of this x. When we evaluate this, we have negative 0 over 2. And negative 0 over 2 is just 0. So our axis of symmetry is just 0. Okay. And we can plot this function down here on the y-axis using our axis of symmetry. Okay. Then we're going to take this x is equal to 0, and we're going to plug it in our function. We're going to get y is equal to, again, make sure you're putting in that value in parentheses. 0 squared is actually just 0. So works out nicely here that our vertex is actually just 0, 0. And again, I'm going to try to plot this point right on the origin there. That's 0, 0. So we've located the axis of symmetry. We've located the vertex. Next thing you should take a look at is you should be taking a look at a. You should be saying, is a greater than 0 or is a less than 0? Right. And because a, or is a less than 0? And because a is greater than 0, we know that our vertex is a minimum. Okay. We know that that is going to be the minimum because a is greater than 0. So I'm just going to do a little erasing, and then we're going to take a look at a table of values, plug in a couple of points, and begin. So just like with most table of values, we're going to use the table of values negative 2, negative 1, 0, 1, and 2, negative 2, negative 1, 0, 1, and 2. Good thing is we already know 0, that's 0, 0. Taking a look at the function, if I take negative 2 and I insert it into x squared, right, because this is y equals x squared. Let's see, let's write that somewhere. The function we're doing is y equals x squared. Y is equal to negative 2 squared here is 4. So we're going to put a 4 here. We're going to get a graph it. Negative 2, 1, 2, 3, 4. Somewhere over there. And we're going to plug in negative 1. Y is equal to negative 1 squared. And that is just equal to positive 1. So negative 1, 1. And here's the good thing about the axis of symmetry. Once you have points on the left side or the right side of the axis of symmetry, the graph is symmetrical. So negative 2, 4. This is 2 points away from the axis of symmetry. So I can go 2 points to the right of the axis of symmetry. Negative 1, 1 is 1 point to the left of the axis of symmetry, so I can go 1 point to the right of the axis of symmetry. And then I'm able to just plot up and graph my points here. Okay, and you do that as best as you possibly can, and you're looking at a graph right there. There's y is equal to x squared. I'm going to try another quadratic equation for you. This time it's going to be a little bit more difficult. It's going to require a little bit more mathematical processes using the table of values. So let's take a look, and this time I'll leave the function up. We're going to take a look at y is equal to negative x squared minus 8x minus 17. Okay, and the reason I'm using this function is because this function actually proved to be a little bit of a challenge to most of us on the assignment that was due yesterday. So, first thing we want to do is we want to find that axis of symmetry, and we're going to use AOS. Should be like clockwork now. It's negative b over 2a. Negative b, so again, we're taking the negative, then we're inserting b. B here is negative 8 over 2 times, and a here is negative 1. So that's going to be a positive 8 up top, divided by a negative 2. So this here is negative 4. So my axis of symmetry is x is equal to negative 4. Okay. Now we need to use that. We need to use that negative 4, and we need to plug it into our function and evaluate the function. Once we're done evaluating the function, we will then have our vertex. Before we go to evaluate the vertex, I'm going to graph that axis of symmetry. So the graph is symmetrical somewhere around this line here, x equals negative 4. I plug that in. Again, here's where we are making a mistake. You want to make sure that that negative comes in, then you insert the negative 4 in parentheses, and then square it. You don't want to just get rid of this negative here. That is a very important piece of the graph. So you want to make sure that you use it appropriately. And then we drop in the negative 8 here, negative 4 minus 17. Okay, and I'll get rid of this. So y is equal to, this negative drops down. Negative 4 squared is 16. That makes this negative 16. Then we get a plus 32 minus 17. Negative 16 plus 32, that's going to be a positive 16 minus 17. So y here is actually equal to negative 1. So it looks like our vertex is negative 4, negative 1. So it's going to be right there. Okay. Now, a here happens to be less than 0. A is less than 0. So that piece right there, that vertex, is a maximum. Okay, so we know that that's the highest point of the graph. The graph's not going to go any higher than that vertex piece. I did not mean to erase that. Okay, definitely did not mean to erase that. Y is equal to negative x squared minus 8x. Okay. All right, now that we have our axis of symmetry done and we are done with our vertex, we've located that as a maximum. The last thing that we need to take care of is that we need to create a table of values, graph a few more points, and then we will be in business here. So again, we wouldn't want to use negative 2, negative 1, 0, 1, and 2 here. And you should be saying to yourself, well, I think I know why we don't want to use them. Well, negative 2, negative 1, 0, 1, and 2, those are all points on the right side of the axis of symmetry. So what I'm actually going to do when deciding what my values are for my table of values is I'm going to go 2 to the left of the axis of symmetry. So I'm going to start at negative 6. Then I'm going to use negative 5. Okay. We know what negative 4 is. We just evaluated that. And then I'm going to do negative 3 and negative 2. The good thing is if I can get negative 6 and negative 5, I can just use the counting because of the axis of symmetry to actually figure out what negative 3 and negative 2 are. So, again, we're evaluating at negative 6, so that negative is important. We insert the negative 6 squared minus 8 times negative 6 minus 17. This is negative. Negative 6 squared is 36 plus 48 minus 17. That is 12 minus 17. So this is negative 5. So negative 6, negative 5. Negative 6. 1, 2, 3, 4, negative 5. And that makes sense, right? If your point had been somewhere up in this area, you should have known that you were wrong because the vertex was the maximum. So your point could not have gone over the maximum. So we're in good business right now. And take this negative 5. I'm just going to erase here the pieces that are important. Go ahead, take this negative 5, 25. So this is negative 25 plus 40 minus 17. That's 15 minus 17, and that's negative 2. Negative 5, negative 2. So again, here's how I get the rest of my points. Negative 5, negative 2 is 1 to the left of the axis of symmetry. So using the symmetrical property, I can guess that negative 3 is going to be negative 2. And then negative 2, well, negative 6, negative 5 is 2 to the left of the axis of symmetry. So for negative 2, I go 2 to the right of the axis of symmetry. And I can almost guarantee that that's negative 2, negative 5. So when I go to graph, again, not the most excellent graph in the world, but it does the trick. Okay. Make sure that you are labeling all pieces of your graph. That's your axis of symmetry at x equals negative 4. Our vertex, you want to make sure that you are identifying these pieces before you are actually going into graph. Okay. If you have any questions or would like to see another example, make sure that you reach out to me and ask, and I will happily set up a time to chat with you guys about this stuff. Always, always remember, you can't just get rid of this negative sign out here. Very important. And insert your values in parentheses before evaluating.